Okay, we've got a probability worked example here. This is a Venn diagram type problem concerning 200 employees. Let's have a look. In a company, the 200 employees are classified as full-time, part-time, or contractors. Table below shows the number of employees in each category and whether they walk to work or use some form of transport. Okay, so there we go. There's the table. Full-time, so part-time workers. There are 35 of them that walk, and so on. The events F, H, and C are that an employee is a full-time worker, part-time worker, or contractor, respectively. WB, the event that an employee walks to work. Okay, so we can see all that, can't we? An employee is selected at random. Find the probability. Or the probability of H, so that the probability that they're a part-time worker. Okay, so I've replicated the table here and put the totals in down the side here, so we can see that if we add across, we get these figures, and they add up to 200, and if we add downwards, we get these. Unfortunately, they add up to 200 as well, so that means we've done the addition correctly. Okay, so the probability that it's a part-time worker, well, we've got 110 of them out of 200, so that is quite simply 110 over 200, which is 1120, so 0.55. So that is part A. The probability F intersection W prime. Okay, so what we're looking for here is the probability. So prime, it means the opposite. So what we need to do is find out the intersection, and then take the rest. Okay, so the intersection of F and W is this 2 out of 200 here. So essentially, what we're looking for is the probability. Well, it's 1 minus this 2 out of 200. That's another way of looking at it. So we could just say take 2 out of there. That leaves us a total of 198. So it's 198 200, so 99 100s, and that's equal to 0.99. So that's kind of what we mean there. And usually with these things, we have to kind of just build it up and work through it. Part C is the probability of walking. This employee walks, given that he or she is a contractor. Okay, so basically what we are now doing is with this conditional probabilities, we're confining ourselves to this row here. And there's only 80 in this row. 30 of them are the walkers. So the probability of walking, given that we're just confined to this, is going to be 30 out of 80. So that's 3/8.375. Good. Okay. Let B be the event that an employee uses the bus. Given that 10% of full-time workers use the bus, 30% of part-time workers use the bus, and 20% of contractors use the bus. Draw a Venn diagram to represent the events F, H, C, and B. Okay, so these are separate, aren't they? These are mutually exclusive. You're either a full-time worker, a part-time worker, or a contractor. But we've got any of these might actually be using the bus. Okay, so how do we actually know what goes in this bit, the non-bus users, and this bit, which are the bus users? Well, that's what this tells us here. So we know there's 10 altogether in F, because that's what that figure there is in that row. And it's 10% use the bus. So we're going to split that 9 and 1. That gives us our 10% there. 30% of part-time workers use the bus. So that is 30% of 110, which is a total part-time worker. And then 20%, that's 20% of this figure of 80. So that's what we've got there. Draw a Venn diagram. So we've done that. That's part D. And then find the probability that a randomly selected employee uses the bus to travel to work. Okay, so so basically that is given by the count within this B ellipse out of the total of 200. And if we add these up, see that comes to 50. So that's 50 out of 200, which is equal to 1/4. So the probability that a randomly selected employee uses the bus to travel to work is 1/4. Okay, so that's it. Hope that's useful, and thank you for listening.